Hi, I'm Michelle. My pronouns are she, her, and I'm a senior software engineer at Netflix. Today I'm going to talk to you about what I've been working on with my team in content engineering. For everyone here and watching virtually, feel free to post any questions in the Slack channel or afterwards, and I'll answer as time permits. So one question I'm going to answer now is that I have no power to renew or greenlight your favorite show. If I did, there would be a show called Cake with Michelle, where I just eat cake and tell you how much I'm enjoying it. It would be really boring for you, but like super fun for me. But what I can do is help artists and creators make the Netflix originals we all know and love. So my team is called Production Infrastructure Engineering, or PI, which is also awesome, is responsible for helping to make sure that they can work every day, all day, and not worry about the infrastructure powering their work. So here's what we're going to learn about today. What technology did we use? What was the problem we were solving? Who were the users? How did we make Netflix Workstations? What did we learn from making Netflix Workstations? And finally, what's next? So before I get into the problem and why we did this, I always like to give like a quick teaser trailer of all the technology I'm going to touch on today. If you are unfamiliar with any of them, don't worry. I'll be kind of defining as I go like what they are and how we use them and what they're good for. And if you're an expert at any of them, please stay because I've got a lot of questions for you. So at the top, there's Go having a cup of Java. We use Salt for configuration and Spinnaker for fleet management. Images are made with Packer. We use a lot of AWS services, but I wanted to highlight EC2 as the actual instances, DynamoDB for the data, and SQS to support our event-driven microservices architecture. Those EC2 instances come with NiceECV, which is one of the ways we actually remote into the instances, and the other being Teradici. So what was the problem? Historically, artists had machines built for them at their desks and only had access to the data and applications that they needed while they were in the office. This system allowed for fully on-prem solutions that ended at the door. There are a few reasons why this is no longer feasible. First was the vast shift to work from home in 2020. We had actually already started this project late in 2019, but it really accelerated our timeline. While people are sometimes beginning to come back into an office in some regions, the work landscape has irrevocably changed, as you all know. So there's a second reason, which is actually our initial project mandate, because in 2019 we did not know everyone was going to be working from home, is that Netflix wants to make content at an unprecedented scale. So I've worked in entertainment almost my entire career, and never on this many projects at once. There are simply not enough artists in a single geographic region to support the Netflix scale of content. Production needs to meet artists where they are instead of trying to bring people all in one place. Finally, by taking down traditional barriers to entry, the industry and Netflix becomes more accessible to all types of people. Losing access to great talent because they live 100 miles from the closest office or have mobility restrictions is simply not acceptable. That's weird, double. You didn't get to see the picture for a second. Okay, so a question that comes up is why not just ship a computer? Seems much easier, right? So the North Star for Netflix Workstations was to provide infrastructure for artists to get a one-click experience from sitting down to working on a shot. But that can also be accomplished by building a computer and sending it to them. So why not do that instead? The answers are flexibility and security. Production needs can change fast. New cameras and new software make it an ever-evolving space. By creating cloud-based workstations, adding anything from new features to security patches can be quickly distributed to all of the workstations or a specific workstation. User can switch from one operating system to another by just opening a new window and sitting in a new computer. Instead of waiting for a package to arrive in the mail, they can get a more powerful GPU or larger storage with a quick configuration change. Workstations, like many cloud-based applications, are not designed to be permanent. Artists are renting a workstation, not buying it. The downside to that is accounting for other features that come with a single desktop. So something like persistent user settings. When working on a desktop, user and software settings are just sitting on the hard drive, and wherever the software puts them, it doesn't matter, it's always saved. With the cloud-based solution, we had to be more methodical and save crucial settings to persistent storage, associate that with a user, and attach the storage to all future workstations. So there's always a trade-off when you're going from one to the other and making sure you can at least meet those table stakes of what people are used to. So asset security is critical. Inside studios, files have traditionally been passed around many different ways, from FTP to email. Every time a file gets moved, it creates that access point for interception. By having all the files on cloud storage along with the virtual workstation, files do not have to pass through those intermediate services. It allows for granular controls of a file's lifecycle and access, since they never leave that original storage they were on. So, who are these Netflix workstations for? When designing Netflix workstations, we had to balance the needs of three significant personas. Those are artists, technical directors, and pipeline engineers, as well as the many supporting teams that made this happen, such as storage and networking and all those experts. So artists want to focus on their art and not on technology. They're the main end users of a workstation. They want to get to work immediately and not wait for a computer to boot up or figure out what files they need to download or anything like that. And artist workflows can vary wildly depending on which step of a film or TV production they're on, but kind of the basic needs of any artist is the same. So I'm going to dig a little deeper into these users and kind of give you more of what they are. So artists can have source files that includes anything from original film plates to reference images to LiDAR scans. They can be anything, huge amounts of data. The artists then use digital content creation, or DCC applications, to create new images. They could be final drawings, or they could be blueprints for a render for the final frames. These new files then have to be shared for review, and all of these steps would ideally be completed on a Netflix workstation, which includes other tools and plugins to manage that whole pipeline and that iteration, such as task management and shot reviews and all that. Our other users are technical directors. They have both artistic and technical knowledge. They work daily to improve that artist experience. They need to be able to create scripts and plugins for the artists and debug all their problems. They also need to be able to do all the same tasks as an artist, so all those DC applications to troubleshoot any configuration, help the artist get their shot done. And it's the technical directors who decide on the software and ensure the artists are on the correct configuration for their tasks. They're not on the wrong version of the compositing software or the plugins changing things to the wrong color. So pipeline engineers focus exclusively on creating the pipelines and the workflows. So I'm stepping out further and further from the actual shot work. Their portfolios can include things like file orchestration, license management, or anything else needed for the artist to complete their work. They glue the pieces of the pipeline together with Netflix workstations in the middle and they make sure they can work as efficiently and smoothly as possible. So my team started with a strong emphasis on building this complete product. So the plan was always to move towards a more self-service model and get the technical directors and the artists more involved in figuring out what they want and building on the system. But the next step is to actually build a platform for the pipeline engineers to build on top of. So to provide that curated artist experience, and they can have any customization they want and just have a really strong base infrastructure underneath. So how did we make them? Let's get to that meat of that technology. So starting a new project can involve making hundreds of technical decisions, both big and small, from picking a tool to naming a variable, right? It can be overwhelming, wondering if a choice made now will ruin an engineer's day a year from now. Well, I'm here to tell you not to worry about that, because it definitely will. So have you ever worked on a legacy project and thought, wow, the engineer that wrote this was a genius and everything they did makes perfect sense? Of course not. The engineers before you were always the worst because they worked with the constraints of what they knew then, not what you know now. So now that I've tried to completely demoralize you, I want to give you a little hope. There are techniques we use to reduce the bad choices future engineers have to live with. If you've seen any of my other talks, and I'm sure you have because I'm really famous, you'll remember I have a catchphrase, do less, accomplish more. That is, focus on solving the problem and only build what you absolutely have to, what is completely unique to your business problem. So Netflix values this culture of freedom and responsibility. It's on our culture memo, and we're all about it. Yet a commonly used design philosophy is that of the paved path. Those are tools and practices that are widely adopted and supported. Engineers can choose any tool or build any service they want, but it'll be much easier on you if you use one of the paved paths. That matched my personal philosophy as well and guided many of the team's choices. Of course, sometimes you have to stretch a metaphor super far and pave a new path. You need to create or implement tools that haven't been used before. That's when I put a premium on solid community adoption as well as reusability. If one service can solve multiple problems, it's more likely to get used for the long term. So in order to explain the technology behind the large project, I've broken down Netflix Workstations into the following main components. The first is fleet management, which is making sure workstations are available and tracking their individual life cycles. The second component is configuration management, which makes sure the workstations can be designed for any artist need, and whether it's installing an application or editing an environment variable, anything that can be done to a computer. So the next two are package and image management, which are kind of both sets of configuration management. Package management handles individual packages like a single software or a single environment variable, while image management handles that collection of packages, such as specifying all of these packages are required for compositing artists. All of these packages are required for previs artists. Together, they ensure configurations are immutable with a clear history for stability and observability. The fifth component is user access, or role-based access control, RBAC, and how the right user gets the right workstation and access to the right files, which, as you know, is very important. Finally, the remote display protocols are how the user connects to and interacts with the workstation remotely. So let's start with fleet management. So fleet management handles the life cycle of a given workstation, as well as pools of workstations with identical configurations. Pools are similar to an auto-scaling group in AWS, but the control plane of the Netflix Workstations handles all the scaling manually, automatically, instead of letting ASGs do it. The control plane is a collection of Java Spring Boot services, and we use Spring Boot because it allows for easier creation of Java applications by kind of abstracting away some of the common tasks. Java and Spring also have a strong paved path at Netflix, and many of our services use it, so it was an easy choice. So that control plane tracks the fleet needs and alerts Spinnaker to execute them. So Spinnaker describes itself as an open source, multi-cloud continuous delivery platform that helps you release software changes with high velocity and confidence. It's a common tool for releasing and maintaining services, and it's on the paved path again. Spinnaker also controls the creation and destruction of those workstation pools. So base configurations have a few variables that mix and match for each use case. Spinnaker uses pipelines as instructions for creating those pools of workstations, which it calls clusters. Pipelines can be accessed through an API and allow for variables and expressions. We set up a variety of variables that can be mixed and matched for each use case. So, for example, artists could need a GPU when doing graphic-intensive work, or extra large storage to handle file management. Some artists need CentOS 7 to support their software, and others require Windows to kind of minimize the latency and get them working as fast as possible. The workstations, we go as close to the artist as possible and support a growing list of regions and availability zones. So the control plane directs Spinnaker pipelines to run whenever it needs a new pool or more workstations. It connects to the Spinnaker clusters through their API to terminate a workstation once the artist is done with it, or remove whole pools once that configuration is stale and the technical directors have decided we don't want to use this one anymore. And in each workstation, there's a Golang agent, which provides the heartbeat and other information about a workstation back to the control plane. The agent lets the control plane know the workstation is still up, in the correct state, or needs attention, and which part of the life cycle it's in. We chose Golang for the agent because it makes it really easy to cross-build executables for the different operating systems, which was a very early requirement for this system. So configuration management starts at the control plane, but the details of software installation and configuration is handled by SALT. We needed a system that could manage hundreds to thousands of workstations while being highly flexible and easy for anyone to jump in and create new configurations, and not just the platform team. So this is where SALT comes in. The control plane uses SALT to make operating system agnostic declarative statements about how to configure a workstation. It uses a combination of YAML, Jinja, and Python. It has a bunch of built-in modules, or you can build your own, from installing a package to file management to almost anything. It also allows for logic statements to handle situations such as mount this storage in only this environment, or only run this script if this file doesn't exist. So here's an example of a SALT formula. This is the equivalent on CentOS of running yum install this lighting software. So even though this example references CentOS, the module is actually OS agnostic, and I can use the package.install to install on CentOS or Windows, and behind the scenes it figures out, is it yum, is it chocolatey, how are we going to install it? So today we have over 100 different packages from workstations from all over the place, from the software to the registry to the environment variables. So SALT, why did we select that over configuration management tools such as like Ansible or Terraform? Because it was recently used in other Netflix projects, and people have given it really high marks, and as well as being Python-based. Python is kind of the standard language for visual effects and animation tools, and it's used to build a lot of those plugins and tools that the technical directors and the pipeline engineers are used to. So it kind of creates those bridges to them and working directly on the shows. So we wanted to make it more available to people and use tools that people are familiar with. So initially, we used SALT formulas directly, allowing for fast change and super quick deployment. Everything was always the latest, with no ability to lock to a specific version. Sounds great, right? So as the project grew, this like wild west of formulas became more challenging to manage. Any code that was deployed, you couldn't see exactly what it was or when it was changed or what was going on with it. We created this package management system that wraps around the salt formulas to kind of enforce some rules and some control. The first is a template for all the formulas. This makes it easier to avoid naming conflicts and enforce rules such as, this formula is not going to run successfully unless we know the user's name, or this formula is a PowerShell script, so only run this on Windows. The second is that all packages are immutable. To use a package on a workstation, it needs to be published to a version. And if any changes are made, it needs a new version, no matter how small the change. This makes it a lot clearer what was run. It also allows for checks at the publishing stage, such as syntax and testing. So if this sounds like Git, it's pretty much that. We're using it to create versions and control and making it like a little harder to deploy, but a lot harder to know what's actually happening. Okay, so I'm going to go in deep into image management. The image management process has gone through multiple iterations as we learn more about the users and observed how they actually use the product. A workstation goes through 3 configuration stages: bake, run, and acquire. The different iterations will show how we move logic around to better serve the user's needs. And I kind of like this case study to show that we made assumptions in the beginning that we weren't right as we worked on it. And then those second assumptions weren't right, so we moved to another one. So I think it's fun to kind of see the evolution of the product and not just say that we got it perfectly right the first time, because nobody does. Okay, so this chart shows at the bottom those 3 phases, right? Bake, run, and acquire. And then the actual logic is at the top, and they'll kind of be moving around based on the iteration of the product. So all of the deployed workstations start with an AMI. An AMI is an image used to launch a workstation in AWS. The bake stage is a process of turning a series of instructions into an immutable image. If you're familiar with Docker, it's like a list of Docker instructions that turns into a Docker image. Spinnaker then can use this image to create that pool of workstations pretty quickly. However, the process of baking can take a long time depending on how much you're installing, how big are those software packages, things like that. We wanted to ensure that while we were in the alpha stage, we could quickly release new features. We didn't want to be held up by kind of long waits while the AMI rebaked. So we only included minimal logic in the bake stage. So just like the operating system and the agent, and that's all they pretty much got. Spinnaker creates the workstation during that run stage. The workstation now has that agent, and is marked as available in the control plane for someone to acquire. There is no other configuration happening in the first iteration of the process at that run stage. Just booted that workstation up and said, now we're ready to use it. So the acquire stage is when a user says, I want a workstation right now. I'm ready to get to work. In the first iteration, most of the software installation and all the user configuration happened during the acquire stage, a kind of just-in-time approach. Like making a sandwich once the order is placed, there was no pre-ordering before the user requested the workstation. This approach had maximum flexibility, but led to long wait times. So as someone who will only get takeout at restaurants where I can order ahead, so it was ready as soon as I get there, this was totally unacceptable. I don't want to wait. And they needed to do our artists. So the long wait times led us to rethink this and move the software configuration and installation to the run stage. So this is the second iteration. This creates a pool of workstations that have specific configurations instead of just the OS. It's this is the compositing configuration. This is the previs configuration. However, there are kind of 2 risks with this method. The first risk was making many, many pools with slight variations. It turned out not to be too much of an issue because in practice, the usage patterns of artists were not as diverse as initially thought. A lot of people use the same configurations. This meant that while there were many pools, instead of the number didn't grow to be unmanageable. Usually it'd be a group of people use one configuration and then they want to do an update, they do a new configuration, and then we can kind of destroy the old set of pools so they're not around anymore. The second risk was inefficiency. So there were always idle workstations ready to go for the artists, which meant they were just kind of sitting around, lonely, unused, racking up AWS bills. This is an intentional decision in favor of usability over efficiency, which we had before. Of course, this means time for that third iteration. The third and current, but probably not the last iteration, is pushing the software installation all the way back to the bake stage. This is like having a library of blueprints instead of a bunch of empty houses sitting around with no one living in them. It's less wasteful because workstations can build from baked images very quickly as they are needed. But don't forget, we did not do this initially because of those long bake times. We don't want people waiting around 30 minutes every time they had to change. However, things have changed a little bit since then. The process has now come full circle, but instead of abandoning baking, we improved the process and developed better tools that allows for concurrent and easier bakes, integrating a lot with Packer and making it a lot easier to do the bakes. Though the team also kept those other options. Both those iterations are all still possible as backup, because one of the many lessons we learned from building a new project is kind of hedge your bets, right? So the technical directors who handle the configuration choices are encouraged to give some time between creating a new one and telling an artist to get a workstation. So it gives us that process gap instead of trying to solve it with technology and run to other problems. So like, hey, when you make new configurations, you can't have people use it right away. You need to give a little warm-up time. So maybe put that in your process a little bit. So kind of moving the process around. So that's kind of with all projects. There are no perfect choices, just a bunch of trade-offs that kind of maximize user experience, cost, and technical efficiency. So the crucial part of any remote workstation experience is connecting it. We currently use two different remote display protocols, NiceDCV and Teradici. When deciding on which remote display protocol to use, the user must know how they want to connect. This is not decided by the artist, but rather by which workflow they are using. Generally, it's the pipeline engineers who originally got the artist team up and running decide on which workflow they want to use. So Teradici is a commercial solution consisting of a workstation agent, software, hardware client, and gateway components. NiceDCV is an AWS service provided on any EC2 instance and allows for browser-based connection and application streaming. Application streaming is pretty cool because it allows for kind of very streamlined performance. So artists, instead of getting a full desktop, will just open their browser window and get an application. They can open another browser window and get a different application. And it's not like they have desktops and desktops. It's just a cool workflow, and people use it different ways. So kind of for both these protocols, latency and peripheral connectivity were kind of the vital features, right? For example, if an artist can't use a Wacom tablet or 2 giant monitors or 5 giant monitors, they won't be able to do their work, and they won't want to work on a remote workstation and will ask me to ship a computer to them, which I do not want to do. Okay, and then initially, all users acquired and accessed Netflix Workstations through a UI. Key components needed to allow for improved self-service are kind of in that UI now. This includes giving technical directors the ability to create configurations, control access to them with the role-based access control. The UI is also where we use for operators to visually check on the health and usage of workstations, such as checking logs when a support request comes in or making sure an artist is using the correct workstation. There are dashboards to check on common needs, such as are we out of licenses, or did the autoscaler go haywire and make 1,000 workstations with Among Us installed instead of compositing software again? That didn't happen. Over the past year, we realized that stakeholders were less interested in kind of the opinionated product and more interested in this robust, customizable platform. The current focus is shifting all of that stuff out of the UI to API, and pipeline engineer partners will be relied on to control that kind of customized artist experience. The core strengths of Netflix Workstations will be in a common platform attributes, such as reliability, observability, and customizations. By focusing on those and kind of strong partnerships, they can be leveraged for bigger impact. Kind of moving it all out of the small circle and letting everyone use it. So kind of just show the full workflow in one pretty pink chart, put it all together. So a workstation starts with making the AMI. Is where the majority of the configuration is happening. Then Spinnaker handles the fleet management by turning that AMI into a pool of workstations. After that, the agent starts up and makes the workstation available for acquisition. Finally, once a user requests a workstation, they connect to it with the remote display provider. And when they're all done with it, the workstation gets terminated and the cycle starts all over again with a brand new workstation. The system is designed for the artists and everyone who supports them. Artists can get onboarded no matter their geographic location to accommodate dynamic production schedules. They can get any workstation they need with a configuration change instead of having to wait for a new one to arrive in the mail. And technical directors can quickly modify and control configurations to maintain stability while trying out new tools. And finally, pipeline engineers can build on top of the platform to create a different experience to a different specific workflow. So what did we learn? Everything was new when this project started. It was new roles, new teams, an empty repository. We kind of made the best choices with the information we had, then pivoted when real-world users showed us a different way. Here's some of what we learned about designing artist-driven technology. So nothing can be taken for granted when making a significant leap in technology. The new technology of cloud-based workstations must, at the very least, match the old experience of dedicated on-prem workstations, or the user won't use it. For example, users rely on their software settings to remain in place from one workday to the next, but it's not a given on a cloud-based workstation. Therefore, it's essential to learn all the aspects of a user's workflow so nothing is missing when they get to using it. We focus first on technical flexibility instead of the artist experience, but artists need custom workflows, not standard solutions. By initially building the entire product, we were painted into this little corner. We were on the hook for making everything, but unable to deliver that needed customization. Instead, we're pivoting to that platform to build a strong core and allow for partner customization. Empowering others to develop with you gives your team more leverage than they could accomplish as individuals. The more the system makes it easier for others to contribute, the better adoption and the better iteration. The engineers need to help each other. Additionally, the artists require engineers to move fast, but in this case, we can't break things. A seemingly impossible mandate, but one in which to inspire. It isn't fun when someone's first experience with a product isn't delightful. Observability and testing can seem like things that can be cut when those timelines compress and suddenly everyone's working from home in 3 months instead of the years you thought you had to build this product. But that can come back and haunt you super fast. We've committed to improving in this area, and such as adding automated testing, clear failure modes, things like that. And finally, we need to address one thing at a time, from the micro to the macro level. From small tickets and small pull requests to small releases. Every time we tried to abstract too early and build for every use case, it never got right. So doing one thing, validating and iterating, is how we're going to know a system's robust and kind of getting on the right track. So, like the Christmas Prince universe, crossovers and spin-offs make things more fun. Netflix Workstations are one part of a technology ecosystem designed to help content creators make feature films and television on an unprecedented scale. This ecosystem consists of many other teams that help use our infrastructure in new and exciting ways. We'll be collaborating to plug workstations into more and more workflows so talent worldwide can be part of making diverse content. Okay, as part of that, here's my obligatory plug to be a part of the team. If this got you excited about all the possibilities of building new technology for a new studio, please reach out. I'm happy to answer questions now. It looks like I have a huge amount of 5 minutes, or throughout the conference, I have an AMA actually right after this. If you want to join me on the midway, it's right next to where we had lunch. Or feel free to reach out on LinkedIn. Just make sure to send a message or I'll think you're a robot. Thank you for listening. Thank you to all my stunning colleagues, without whom there'd be no Netflix Workstations. So I'll repeat the question. It was about what happens when artists are working somewhere where they don't have good internet and can't work on your cloud workstation. We've done a lot of tests in this, and it's very difficult. But it's about, that's where we try to get to close as them as possible and kind of get that latency down. And it's a lot of that is on that both the regions and the remote display protocol will cache things, they'll bring them out, and we'll find ways of getting to it. But that's definitely somewhere where we can improve. And it's also why we build one region at a time. We build this one region, see how the people there are using it, what do we get out of it, and then move one to one. I have gotten this question before, like, what if people want to work outside? It's like, well, you can't light an image in the sunlight. So I at least can beat the people won't be working in the park. So they're at least working in a building. So I at least get that for free. So far, so good. I mean, we definitely, like I said, this is a brand new project. It's not perfect. There's plenty of things to improve. But, we get stuff all the time when trying to do it. But yeah, video editing can happen on a cloud workstation. And people are working on these super high-res images and doing all sorts of really cool stuff with them, and they're able to do it on their cloud workstation. Yeah, so the question was, do I have the same problems as game streaming where you're trying to collate the data to the region that the person is working in? Yes. I mean, that's part of that slowing down the latency. Like anything that can be as close as possible to where they're at, and building that stuff up. So yes, that's definitely something we have to address as we build region after region and kind of spread around. Yeah, so actually the most important thing for us was to start with how do we match their previous experience? Like we don't want it to be worse because then they're never going to use it, right? So after we get to that point of solving all those back-end difficult challenges like the latency and making sure their Wacom tablet works and making sure it comes up quickly and the files are all there and it doesn't just crash in the middle of nowhere and they don't use it. So all those kind of table stakes, that's what comes first for us, right? And make sure that's working. And then you can get to you can kind of let your imagination run wild. That's why I like talking about nice DCVs like application streaming, because that's like a totally different workflow than just using a desktop with a bunch of other stuff on it. So I think it'll change things as people get used to it. And also that whole thing of changing one thing at a time, right? We don't want to try to change the entire workflow at once, because there's that mental load of learning new ways to do things. So first, we just want to make sure they can do their exact work wherever they're at, and then it's well, maybe there's other more efficiencies we get out of doing this that we can add into the workday. Yeah, so the question was about collaboration. Are people using the same workstation at the same time? Right now, no, but that is something we explored specifically for reviews, right? Oh, I'm working on this, supervisor, can you remote in and look at what I'm working on, right? So that's one of those things that we're looking into, but it wasn't the critical kind of MVP path, but it'll be really cool when it does. So that, you run into all those is it gonna slow it down? What if they're in another region? What if, we don't want to, what is the identity story for that? So it kind of opens that can of worms, but it also opens for a lot of really cool collaboration. So you gotta solve for both. All right, I am out of time, but thank you. I'll be just heading over to the Midway to do an AMA we can talk about this, we can talk about life at Netflix, jobs, what the team is like. Happy to answer any questions. Thanks, everyone.